WASM's been promised to us as a solution to the performance issues of JavaScript for a long time. We've seen a lot of frameworks trying to rethink the web with things like Go and Rust in order to make our sites as fast as possible. Well, WASM comes with a lot of, peculiarities that make it not the best choice for doing traditional web development. And if we're going to be realistic, we have to accept that most web devs primarily know JavaScript. That's why there's so much exciting development in the runtime world, taking the code that we're already writing in JS and making it work in a more native way, be it with Bun and its crazy Zig bindings, or static Hermes and all the crazy things Facebook and Amazon are doing to make your React Native apps super fast at the speed of assembly in C. But what happened to WASM? What happened to this promise of making the browser way faster? And what happened to JavaScript? What if we could just compile our JavaScript into WASM the same way something like static Hermes is letting us compile it into assembly? If WASM's so much faster, why can't we do that? That's a great question. And there's a really interesting dev working on a really interesting project. And I want to talk about that today because Porffor is a fascinating attempt at rethinking how we write and run our JavaScript. To be very clear, this is super, super early, not ready to actually be used. People seem to think I'm super excited about and adopting all these bleeding edge things. I don't know if or when I would ever use this, but the potential and the research going on here is so cool. And I want to take some time to dig into it. My face is covering the side here. It's a from scratch, experimental, ahead of time JS engine, compiling your JS code to WebAssembly or even to native code ahead of time. It's very limited, but the developer is now getting to work on it full time, and I'm very excited to chat a bit about it. If we look at the playground here, we see this simple isPrime function. If number is less than 2, return false. I is 2, I less than number, I plus plus, return false, return true. Just a quick way to check if a number is a prime. And while counter is less than or equal to 10,000, we run through this. And we use porffor.numberlog to actually log that out. And now we see the WASM code that this puts out. And it's very WASM-y. It very much has that assembly vibe that nobody would want to actually write. But what's happening here is it's compiling out this JavaScript code and turning it into WASM ahead of time. So the same way TypeScript's compiled the JS, this is taking JS and it's compiling it to WASM. Note that I said JS though, because it's one of the most interesting aspects of what's going on here. It's not relying on TypeScript as much as other solutions do. So this code executed in 7 milliseconds. If I take the same code and let's hop into my terminal, we'll make a new project. And this paste, change this to console.log. Then node index.js. I have to time this. So it did run very fast as JavaScript, 0.06 seconds total, user times 0.02 seconds. Not quite the 7 milliseconds that we saw here, but not too far off either. But if we look at their promises, things are very interesting. It's up to 18 times faster than Javi, which is, what is Javi? It's an existing JS to WASM toolchain. Run your JS on WASM. Javi takes your JavaScript code and executes it in WebAssembly embedded JS runtimes and create very small WASM modules. If I add a 0 here, how bad will it be? Wrong button. Okay, added a 0, compile in 56 milliseconds, executed 450 milliseconds. If I add the 0 here and run this again, 0.62 seconds. So a decent difference, not massive, but a solid percentage performance win. This is kind of what I expected, though. I didn't think the performance of compiling to WASM would magically be hilariously exponentially better, but I bet if we just call isPrime and then don't do anything. Oh, that's actually slowed it down somehow. No, that's roughly what it takes. Cool. And if I kill the console logs, that tends to be the slow thing in Node. Now they're like neck and neck, 451 milliseconds versus 500 milliseconds. So the performance here isn't going to be like massively better than something like Node, but that's not the benefit. 1 more 0, people are saying. Give it 1 more, see how long it takes? Sure. My computer is lagging now, is what's happening. That might have just killed the tab, is what that did. That is what that did. Yeah. Don't put too many zeros if you don't want your browser to lock up. Regardless, the performance win here isn't huge. It's not like putting it in WASM is magically 1,000 times faster than the JavaScript equivalent. But what it does enable is for embedding it way, way more minimally. Because if you compile your JS ahead of time, you no longer need to bundle something like Node with your project. If you want to make a game with JavaScript that runs on people's computers and is distributed through Steam, now you can take that 90 megabyte binary of Node plus your JavaScript and change the result to be less than 50 kilobytes. It also uses way less memory because it doesn't need all of the JavaScript runtime. It just uses WASM or even native stuff if you compile to C, and the performance can be up to 3 times faster. These are some really cool wins. And if you're a person making the right technologies for something like this, it has the potential to make a ton of sense. I got a lot of really useful contexted info from the Porffor dev, so I'm going to go through that and do my best to honor it. First, we should talk about Honk, because they're a fascinating creature. 19 years old, they were working at Mozilla for the last 10 months, and they just quit so they can work on Porffor full time now. That's really exciting. Wait, they made Test 262? No shit. No shit. That's nuts. That just doubled my confidence in their ability to make this happen. Oh shit, you're in chat. Yo, Canada. Thanks for stopping by. That's nuts. These are the right people to be doing these things. If like Test 262, for those who don't know, is one of the most useful resources to see what features are supported by which JavaScript runtimes. So if you want to compare how JavaScript Core's feature set works compared to something like V8, this lets you see each of these solutions and how much of temporal is implemented, how much of decorators are implemented, all of these types of things. And if this dev is that focused on this type of thing, it makes perfect sense to me that they're the right type to re-implement JS in such a crazy way. Super cool stuff. Yeah, crack. There's one of those rare like 100x devs that knows things I can't even comprehend. So here we have a comparison with V8, SpiderMonkey, JavaScript Core, Hermes, Rhino, and Porffor. Hopefully I'm pronouncing Porffor right. Let me know how much I'm butchering it. And you can see we're still early on a lot of things like these proposals. And when it comes to ES6, not too much implemented. Still not too far from Hermes, but far from having everything implemented. Still nuts to see this much progress on a project that's this early, and also very promising that the dev who made the site for checking is also the dev working on it. I think it's important to contextualize the position of Porffor compared to these other solutions, and Honk did a great job reaching out to me and giving me that context. So I'll do my best to share that. We're going to open up Excalibur. We have a lot of things to put in here. We have V8. We have things like Dino. We have Porffor. We have static Hermes. We have Bun. We have LLVM. No, it's not LLVM. It's LLRT. Sorry. LLRT, which if you're curious about, I'm one of the few people with a video on it. For a long time, I was the only person with a video on LLRT. It is, oops, no, I didn't mean to do that. It is a runtime built at Amazon to allow for Lambdas to spin up faster, and also to ship way less code to said runtimes. So of these, if we look at all the options here, I'll just make this a fancy little summoning circle with all of these options. Where do y'all think Porffor leans? What do you think it's competing with? My assumption initially was that Porffor was competing with static Hermes, which for context, static Hermes is the attempt by Meta, Amazon, and a few others to allow you to compile your type-safe JavaScript code, be it in Flow or TypeScript, to native code. And it uses the type definitions to figure out which memory to map, which types to use on a lower level, so that it can use those type signatures to make more optimal code. And since Porffor is compiling to assembly and then native code with C, the immediate assumption I would have made is that it was close to this. Honk has since made it very clear that is not the case. Their goal is actually a lot more aligned with LLRT. I need to make a spectrum to explain what I mean here. On one axis, we're going to have performance, as in ops per second. And on this other spectrum, we're going to have binary size. These are two very, very different spectrums, and all of these fall in different places. V8s, and I'll say, this is binary size, I'll say big here. Actually, I'll say optimized here, big here. And then I'll say slow and fast here. So this is our rough spectrum. All of these solutions fit somewhere within this. Bun isn't worried too much about binary size because it's worried about performance. So Bun is very fast, but it is not small. V8 is also relatively focused on performance, and it's a bundle that already exists in a lot of things with something like Node. But I would say it is nowhere near as fast as Bun. I'd almost put it like right in the middle. But its binary size isn't the worst, but it's not good. So I'd put that there. Dino, I would say, is a little more performance optimized than V8, but not a lot, because it is still using V8, technically speaking. I also want to change V8 to Node, just to be a little more polite to it. Dino, I would say, is a little faster, bundle size, a little more to consider, because you have to bundle a whole separate runtime for it. And then LLRT, this is where things get interesting, because they're taking a hit on the performance in order to make the binary size, the actual file that has to ship to a machine to run, way more optimized. LLRT is one of the few solutions optimizing for binary size. It is willing to take a hit on performance to get there. That's why Porffor is so interesting, because it's trying to get there without the performance hit. These are arguably two different directions, but the goal is the same, of optimizing how much has to ship to a user or to a Lambda or wherever it has to in order to actually execute the code. Very interesting. It's also worth noting, as chat just pointed out, that binary size and startup cost are linked, which is an important point to make, because having an optimized binary won't make your code run faster. So once it's running, the amount of requests per second you can handle doesn't necessarily go up. But the real win is interesting, which is the actual time to go from not running to running is a lot better when you optimize. I also forgot to put static Hermes in here. Let's do that quick before I forget. Static Hermes is a little more focused on the bundle size, but a ton on the performance. In fact, I would say more so than even Bun. I'd push Dino a little back as well. Hopefully this helps contextualize where Porffor stands. It's a very unique solution, because theoretically it's slightly faster than Node or Dino and other things, but it's not as compatible. There should be a third axis here of compatibility, because Porffor, LLRT, and static Hermes are all losing in compatibility. It's almost guaranteed once you're over this binary line, where you're optimizing your binaries, you're rewriting everything, and now, as such, your compatibility is going to go down. Bun has stated the original goal of being as close to Node compat as possible. It's not there yet, but it's making a lot of progress. And then Dino is effectively fully Node compat now. But these are all the important things to consider as you look at these solutions. Like, yes, sure, there are now more JavaScript runtimes than there were JavaScript frameworks 15 years ago. But the same way most frameworks have some specific goals in mind, these runtimes also have very specific goals in mind. The only ones that are even vaguely close are Node and Dino, because they were created by the same person. So that almost makes sense that Dino was largely created due to the small handful of flaws that Ryan saw in what he created with Node that he wanted to patch up. So he just made a subtle move over with that. Bun says, no, we need crazy performance and we'll eat a lot of cost to make that happen. Static Hermes says, we need a lot of performance and we're going to do the impossible and make a TypeScript to native code compiler for it. Porffor says, what if we could just make a smaller binary for our JavaScript code that executes on users' devices? Very interesting. It's almost taking what LLRT did for servers and trying to do it for users. According to the creator, I'm doing good with the comparison so far. Thank you so much. So as I mentioned before, CanadaHonk reached out and they gave me a ton of really useful context that I want to break down. I could try and paraphrase this myself, but their words are better. I asked a few questions. First off, they confirmed what I was just sharing, which honestly, I stole from them. Most of this video is just me taking advantage of the awesome resources and info they gave me. I started working on this before static Hermes even existed. To compare against that directly, that is much more focused on TypeScript and specific use cases rather than a general JS engine like Porffor. I think people focus more on JITs as they are good for use cases like browsers, thanks to their relatively tiny compilation times. But for some applications, they're not great. See LLRT, which in a way, this shares some potential goals with. I love that comparison. And to, again, double down on the TypeScript thing, Porffor doesn't have more info about what your code actually does, because I don't know when you define something in vanilla JS, if I let some value equal 7, if some value is greater than 7, some value equals high. Since you can write code like this in JavaScript, it's really hard to optimize it, because you don't know what data type or memory allocation to make for a given value. But if I was to use TypeScript to enforce this has to be a number, obviously this code can't be written anymore, but it could be optimized differently. Even if I did number or string, we now know how to define this pointer in a way that we can make things a little more optimal on the native level. But Porffor's goal is to let you take any JavaScript code, as optimizable or not as possible, and handle all of it, the same way something like Bun works, where static Hermes is trying to take advantage of type definitions to make the most optimal possible output. Also to note, Porffor can optimize using TypeScript type info, but not to the same extent as static Hermes. Makes Makes sense to me. So I asked some follow-up questions, specifically, what weaknesses do they see with the AOT model, which is the ahead-of-time compilation. So you put in JavaScript, it compiles to WASM, and then you ship the WASM to the user, versus just-in-time, JIT, where I ship the JavaScript to the user, and then their runtime, usually V8 in the browser, interprets that to be something more performant, which is the just-in-time, right? Is they get the code, they compile it to something else quickly so that it could run more efficiently. And I also asked, how has WASM helped and limited the development so far? This is a response straight from the creator. Thank you again, Honk, for responding as quickly as you did. For stuff like browsers, where you are loading dynamic content, I would basically never recommend it and just stick to JITs, at least for the foreseeable future. I love when devs call these things out. I see so many devs that are like, I made this solution and it works for everything. But Honk is straight up saying, don't use this for loading dynamic stuff in the browser. If you're loading dynamic JS, don't use this instead. Also, things like eval or function definitions won't work since you can't AOT compile them if you don't know all this info at compile time. The other weakness is that since you're essentially reinventing the JS engine as well as the runtime, it will take quite some time to re-implement everything, but it is feasible. I would doubt almost anyone else saying that it is feasible, and I certainly would doubt them if they said they were going to do it, if they weren't literally the creator of the tool used to compare how compatible different solutions are. Almost any other person I would be calling a lot of shit on, but I would be calling shit on them by using test262. So yeah, they can actually do this. To my second question about WASM, they replied, WASM is great for the ecosystem, especially looking into the future. Being able to potentially just give a WASM blob to something like a binary WASM opt function or package, which will optimize it for you, is a very cool possibility. It can be limiting sometimes, but most things I've had issues with are solved in upcoming proposals, like WASM GC, because theoretically that will finally be in the browser. WASM garbage collection is a whole rabbit hole. Man, if you want to see how bad that one gets, I have a whole video, why WebAssembly can't win. And most of this is a rant about garbage collection. So check that out if you want more info on that. It is limiting for some performance, which is also why I started investing in a native compilation by compiling the generated WASM to C themselves, and then passing that to Clang to make a native binary. That's a pretty crazy compilation pipeline. So imagine this. We start with TypeScript, then we TSC that or ES-build that to JS. Then we compile that with a Porffor to WASM. Then we compile that to C. Then we compile that to native binary. That's quite a compilation tree, if I do say so myself. Nuts, but the potential of this is crazy. When you think about it, a lot of technologies are doing things like this already. Like even now, I'd be doing TS to JS to the V8 JIT to some native chaos. So it's not that many more steps, but it is a fascinating build chain. Also, they called out, this is relatively early in a research project, and an important call out here from Defunct, which we'll get to in a second because I want to read the post about it. A new chapter for Porffor. Porffor is my hobby ahead of time JS engine, but no longer. This week, I've resigned from Mozilla after a wonderful 10 months to work on Porffor full-time, supported by Chris Wanstreth from one of his unannounced projects. Wanstreth is a legend, created a lot of things, also original GitHub CEO. And as much as I might not be fond of Ladybird, the fact that he is sponsoring this development changes my tune entirely, because similar to, funny enough, the issues I had with Ladybird, where it felt like it was re-implementing for the sake of it, this is almost the exact opposite. This is looking at this chart, seeing what LLRT and other things were doing, and wanting something in this space in the corner. If I just delete that, there's a huge gap here that nobody was filling, and Static Hermes had no intention of filling. So that's why I'm excited so much about what's going on here, is this dev saw a hole they wanted to fill, they chose to fill it. Obviously, there's another giant hole here worth filling, but maybe not so worth filling the more you think about it. But seeing this opportunity and taking it is very exciting, and I'm pumped that they're getting funding from the original GitHub CEO in order to do it, especially since they have projects that they're actually planning on using it for in the future. So what actually is Porffor? Probably should have started with this, honestly. If you don't know, Porffor compiles JavaScript or TypeScript code to WASM ahead of time, rather than interpreting it or just-in-time compiling it like existing engines do. Compiling JS ahead of time allows some exciting possibilities. You can ship it as WASM instead of needing to ship the whole JS engine, better safety via WASM sandboxing, massive performance improvements compared to interpreting, and potential native compilation too. And what's changed is that they can now bring full attention on Porffor, independent open source as well, and they can continue focusing on things like test262, making sure their stuff passes it, and also maintaining it for other frameworks as well. Super cool stuff. Shout out to Chris for funding this. Huge shout out to CanadaHonk for making this. keeping me informed and doing their best to make my dumbass able to explain these things properly. I'm actually hyped about this. Is it something I'm going to use anytime soon? No. Does it magically make every website way faster? Absolutely not. But is it a promising opportunity to change how we think about JavaScript and to build a new way of building our JS? Absolutely. And if JS is going to be the language of the future, things like this will be necessary. One last thing before I forget, make sure you give Porffor a star on GitHub. I want to see it explode. Even just today, we've had that. But once this video is out, I want this in the thousands, not the hundreds. Support them where they're building real innovation. Give this a star. Obligatory plug for the birth and death of JavaScript, which is one of the best tech talks of all time. It's sadly not on YouTube, but if you Google search this, you'll find it. It's from Gary Bernhardt from over 10 years ago now. I almost want to make a video where I reflect on the points on this and see how much of it did or didn't come true. Because this video explains how JavaScript takes over the entire world. And tools like this are a huge, huge part of how we get there. Once again, shout out to CanadaHonk for doing this and giving me all the information necessary to cover it properly. I'm really hyped with the project. You should give them a follow so you can keep up with it too. Until next time, peace nerds.